Okay, welcome back. Um, Example 3, another mixture problem. So the last problem with the soybean and the cornmeal was a mixture problem. This is also a mixture problem, and they all have the same setup. Okay, so for thousands of years, gold has been considered one of Earth's most precious metals. 100% gold is 24 karat gold, which is too soft to be made into jewelry. Doesn't hold its shape. Most gold jewelry is 14 karat, approximately 58%. If 18 karat gold is 75% and 12 karat gold is 50%. So how much of each should be used to make 14 karat? So they tell us that 14 karat gold is 58%. They tell us that 18% gold is 75 and 12% gold is 50%. So we're going to mix the 12 and the 18. So let X equal 18 karat gold in grams. So it's 75% or 0.75. Okay? Let Y equal the 12 karat gold in grams. So we're talking about the amount for both of these. Okay, I got a little lazy on my definitions. I'd rather you didn't, but if you were to do this, this would be fine. You're giving me everything I need. You're talking about the grams, you're talking about the amount. So 12 karat is 50% or 0.50. All right, so, all right, what do we know? We want it to be 400 grams, correct? So X plus Y equals 400. That's our first equation. This is what I call the quantity equation. Remember? I didn't talk about it in the last problem, but in a mixture problem, we always have a quantity. How much are we putting together? How much are we going to end up with? And then I always talk about the quality equation. And this is my nomenclature, okay? This is the way I think and talk. Hopefully it works for you. So now I got to write my second equation. Well, 18% is 75% or 0.75, and 12, I said 18%, 18 karat, and 12 karat is 0.5. So we know that we're going to have 0.75 times the number of grams of 18 karat plus the number, 0.5 times the number of grams of 12 karat, and it's going to be equal to 0.58 times 400, okay? So when I looked at this problem to begin with, and I always work them before I do them for you, I didn't pay attention, and I figured out what 14 karat gold really is, and it's really 58.3%. And my numbers didn't match the numbers in this example problem. And so I had to figure out why was I off. Well, when I reread the problem, I realized that they just made 14 karat 58% in this problem. It's actually a little bit more, but that's neither here nor there, but it does change your answers if you were being a stickler. Okay, so in this problem, I did the same thing I did on the last one. I used substitution. So y is equal to, no, I solve for x. I solve for x. I already have my notes, so I'm going to do it the way I did it. X equal 400 minus y, and I'm going to take that and I'll plug it in here. So let's do that here. 0.75 times 400 minus y plus 0.5y equals, now if you multiply this out, what you get is 232. Okay? Yes, 232 grams. All right, or 230, because this is actually the quality. So then what we're going to do is we're going to distribute the 0.75 through the parentheses. Okay? When I do that, I'm going to get 300 minus 0.75y plus 0.5y equals 232. 232. Okay, so I'm going to minus 300 and minus 300. I'm going to move my 300 over. I'm going to combine like terms. When I combine like terms, 75 cents, you owe 75 cents, you pay somebody 50 cents, you still owe them 25. So it's a negative 0.25y is equal to, if you subtract these two, you get negative 68. Divide by negative 0.25. Okay. Y is equal to, now we just need to divide these two. And 0.25 goes into 68, 272 grams worth. So we know now that the 12 karat gold is going to be 272 carats. We want 400. Remember, we want 400. So take 400, take away 272, and that will leave you with X is equal to 128 grams. So I'm going to leave you for clearly describing what these numbers mean. But what it means is we need 128 grams of 18 karat gold and 272 grams of 12 karat gold to make a 14 karat gold jewelry piece that's 400 grams. Okay? Very good. Now, so I use what's called the DIRT equation, distance times rate equals time. Some people say velocity times time equals distance, okay? Velocity times time equals distance, where velocity and rate are the same, okay? When I was younger, I learned it as the DIRT equation. It helped me always remember because there's DRT, you're missing the I, but distance, rate, time, okay? This problem is a problem. We've done these in class. We've done one or two of these in class out on the board. When a plane flies, I don't know where family came from. When a plane flies with the wind, it can travel 3,000 miles in 6 hours. So it's going with the wind. When you're going with the wind, you're getting pushed. Okay, it's helping. When the plane flies in the opposite direction against the wind, it takes 10 hours to fly the same distance. So to go 3,000 miles against the wind, okay? Well, find the average velocity of the plane in still air and the average velocity of the wind, I'm glad I didn't follow that up with in still air because it's the wind. So remember, I think I'm funny. Okay, guys. So here's the way I do these problems. They're not necessarily traditional, but what's real important here is with the wind, it takes 6 hours. Against the wind, it takes 10 hours. And we're going 3,000 miles. Okay? So here's the way I do these problems. 6x, okay? I didn't define my variables. Never mind. And I'm not going to use x. I'm going to let p equal the plane speed in still air. Okay? I read the problem. By defining variables clearly, you're telling me, the teacher, or the reader, that I read it and I understand what I'm looking for. W is going to equal the wind speed. Simple as that. There's no more than that. Or velocity of the wind. You could have said velocity of the wind. They mean the same thing. I'm good with either one. Okay? Velocity of the wind, wind speed. Now, here's the way I do these problems. So I'm going with the wind, and it takes me 6 hours. Okay, 6 times the plane speed plus 6 times the wind speed is equal to 3,000. Okay, now we could have said something like this. I'm going to write it up here. We could have said, hey, it's 6 times the plane speed plus the wind speed, and it equals 3,000. Okay, instead, I just distributed it through. what would the other one be? 10 times P minus W equals 3,000. Okay, so this equation is going to be 10P minus 10W equals equals 3,000. I meant to say one more thing about this up here. Okay, so time velocity. Time velocity. Okay. All right. Now, I have a system of equations that I need to solve. I have a negative here and a plus here. I have a 6 here and a 10 here. I want these two numbers to be the same, so when I add them, they disappear. So I'm going to multiply the top equation, everything, by 5. I'm going to multiply the bottom equation, everything, by 3. What I'm going to then come up with is 5 times 6 is 30P plus 30W equals 3,000. Then when I multiply across here, 3 times 10 is, oh, look at that, 30P, just like above it, minus 30W. That's something I want. 3 times 3,000, though, you're probably yelling at the screen right now saying, Miss Sterling, you missed something. And you are correct. 5 times 3,000 is 15,000. Okay? Now, 3 times 3,000 is 9,000. Okay? Plus 60P. These guys get eliminated. That's why I like to call it the elimination method. We eliminated it. And it equals 24,000. All that's left to do is divide by 60 and divide by 60. P is equal to 400 miles per hour. That's how fast the plane is going. How do I find the wind speed? I'm just going to go 6 times 400 plus 6W equals 3,000. Then I'm going to subtract 2,400, subtract 2,400. Then I get 6W equals 600. Divide by 6 and divide by 6. Oh, you can't see. W equals 100 miles per hour. So again, I'm going to leave it to you to write the sentences out stating that the plane's average speed is 400 miles per hour and the wind speed is 100 miles per hour.